So we're here at my house in Avonside, and as you can see there's been a lot of earthquake damage, and most of the damage that we get here, because we're a long way away from where the fault is due to liquefaction. So I'm just going to show you what liquefaction is. So you can see our driveway has bowed up here, and underneath there's all this sand, and this sand has come from a depth of probably a couple meters at least, and some of it might have come from even more. And it's squirted up like a volcano, up a little chamber. If I take some of that sand and I just put it in this jar here, the sand is actually kind of dry at the moment. But when it first came up during the earthquake, it was actually really, really wet. So it sort of sits in. So I've just put that sand in there now. Now I'm going to get some water just from over here to give you an idea of what things looked like when it first came up. So there was a real mixture of sand and water at first. So I'll just pour a little bit of that off there. There was a real mixture of sand and water when it first came out, and the water since has drained into the river. But this will be a little bit of what I would call a liquefaction experiment. I'm just going to get a little bit more of this, sort of like a cooking show. A moment. Okay, that's probably pretty good. Okay, so you can see I've got this mixture of sand and water in there now. And the sand and the water is basically all through there, mixed all through there. So that's what the ground looks like beneath our feet. And during an earthquake, of course, you have this shaking back and forth like this. It really shakes around, the ground shakes around. And what you can see is actually, if we just leave it, the water is beginning to pool up on the top. Do you see the layer of water getting thicker and thicker? You can actually see little bubbles going up through the ground. So the water is actually squirting its way up to the surface, and that water, that thickness of that water layer is getting thicker and thicker. So during an earthquake, you have this water all mixed throughout this sandy material. But when it gets shaken up, the whole material becomes very weak and it flows. It basically behaves like a liquid, and it causes liquefaction. And there's a hard bit on top, a soil layer on top, which presses down on this. And so what happens is, as it does that, it squeezes that water up. And you can see that water is quite dirty there, so it's got a lot of fine-grained material in it. But that's basically what happens. That's liquefaction. So I can take that, I can go back, and I can mix it all back in there again. And you can see there's not that thick layer of water on top as much anymore. But if I have another earthquake, of course, I can shake it up and it'll come back to the surface again. So you can see that we've left it for a few minutes and the water's really starting to build up now. The outside, that's basically this liquefaction.